Welcome back to the deep dive. So if you've been working in, well, pretty much any profession that uses knowledge, which is basically all of them now, you've probably felt it.
Oh, absolutely.
It's that specific, almost unsettling feeling, professional vertigo. The moment you realize that this reliable foundation of technical skills you've spent years, maybe decades
The
building.
very things that made you feel competent.
Exactly. And suddenly it feels like you're trying to build on quicksand.
And I want to stress that feeling isn't paranoia. It's a completely rational, shared experience that's just sweeping across the entire technical landscape right now.
It's validating to hear that because it can feel pretty isolating.
For sure. We saw Andre Karpathy. I mean, this is a programmer who has operated at the absolute cutting edge of AI development for years, just openly state that he has never felt this much behind as a programmer.
Wow, okay, so when someone like him says that,
Exactly. When a figure of that caliber, someone who is usually, defining the cutting edge, says his whole profession is being dramatically refactored, we know this isn't just about learning a new framework or downloading a software update.
okay, let's really unpack that feeling because I think it's so central to what we're all facing. When Karpathy talked about feeling behind, he linked it not to a lack of effort, but to something else.
A failure to properly string together what's now available, he called it a skill issue, which sounds harsh, but he wasn't talking about the old skills.
Right. He was defining a new kind of competence, a new skill set required to actually wield these tools effectively.
Which is why our source material is so spot on and
Yeah.
calls this a phase transition in technical leverage. Not just a new tool, a whole new state of being.
A phase transition, I like that.
It's a profound one. The core change is this massive refactoring of what it even means to be technical. It's shifting the very source of professional power.
And the whiplash is real.
It's so acute. And it's why you, the listener, might feel so far behind. The entire job description is being rebuilt while we're all in the middle of a project. The ground rules have changed, and the old anchors are just gone.
I think the speed is what gets people, it just feels impossible to keep up.
It is impossible if you're trying to use the old cadence of learning, anchored in textbooks and stable architectures that lasted for years.
Right.
Now, the rate of change is measured in weeks. Tools change weekly. Core capabilities keep jumping. And your mental models, they just decay so quickly.
There was a really striking observation in our sources about that decay rate.
Yeah, that if you haven't played with the advanced state-of-the-art models, let's use the hypothetical Opus 4.5 they mentioned, within the last month, your operational understanding of the true cutting edge is already dangerously outdated.
A 4-week decay cycle for foundational knowledge. That's just an impossible pace for traditional learning.
It forces a whole new strategy. The old anchors of competence, of control, of craft. The pride we took in knowing exactly how our system worked, end to end,
All of that is breaking.
it's breaking because it just doesn't match this new reality of stochastic, opaque systems. And that mismatch between the predictable world we were trained for and the chaotic one we live in now leads directly to burnout, confusion, and that feeling of being totally overwhelmed.
So, okay, we can't just throw up our hands. We need a map. And that's really our mission for this deep dive, right? To provide that map.
Exactly.
We're going to lay out a useful hierarchical skill tree that explains why these new skills are so difficult to acquire, and, maybe more importantly, how organizational leaders, and really all knowledge workers, can actually start to adopt them.
And this map, this skill tree, it isn't just for the programmers in the building.
No.
Absolutely not. It is essential for anyone who needs the authority to delegate tasks to these probabilistic machines and ensure that what comes back is useful, reliable work.
So we're moving from a world that rewarded individual execution
High fidelity, perfect execution.
to a world that rewards sophisticated orchestration. The goal is no longer to do the work, but to, design the system that does the work.
That is it, 100%. You're no longer the artisan, you're the factory designer.
Okay, so let's start with the seismic event itself. We have to define what actually broke. We can't build a new structure until we understand why the old one fell down.
Right. And our sources identified 4 key assumptions from the old technical world that are now, for all intents and purposes, obsolete.
So where do we start? The foundation.
You have to start with the foundation. The old world was built on deterministic systems. Completely.
Mm.
The story of technical leverage for the last 50 years was all about writing more correct, more explicit instructions for problems that mattered.
You think of the classic stories, Bill Gates and Windows, for example.
Exactly. You internalized abstractions like data structures, you mastered tools like compilers, and you shaped deterministic systems.
Yeah.
When you wrote a piece of logic, the machine executed that logic the exact same way, every single time.
And there was a weird comfort in that, even when things broke.
Yes.
Because you knew deep down that if you reran the logic with the same inputs, the bug would show up again in the exact same place. You could step through it, inspect the system, ship a precise bug patch, and trace the causality from end to end.
The system had integrity in its predictability, and that integrity created this unbreakable link between authorship and authority. The two were one and the same.
If you wrote the code, you had the authority. You were the only one who really knew how to fix it.
Which is why for decades the wisdom was, keep the founding engineers around, they know the code. That entire regime where expertise was measured by your personal authorship is ending because the unit of leverage has shifted.
From writing the instruction.
To orchestrating intelligence to generate the instruction.
Which brings us right to the first big break. Shift 1. Control is no longer the default. In the old world, you authored the behavior, it was yours, you dictated every outcome.
And now you condition behavior. You're shaping outcomes through influence prompts, context windows, memory structures, giving it access to tools, but you are not providing a precise step-by-step recipe.
So it's less like baking a cake with exact measurements.
And much more like farming. You select the right seed, you prepare the soil, you manage the irrigation, and you hope the weather cooperates. You are shaping, not commanding.
And that probabilistic nature, that's the source of the anxiety, isn't it? The fact that the same input can give you slightly different outputs.
It is. It means that even a perfectly defined workflow can suddenly start to drift when the underlying model gets updated. Or sometimes for no reason at all, just a different stochastic path. And often with no warning.
So the mental shift we all need to make is huge. We have to just let go of perfect deterministic control.
You have to discard it entirely. Mastery is moving away from the old creed of I can make it do exactly what I want every single time to something completely different. I can steer it toward outcome X reliably, I can detect when it's off course, and I can correct its trajectory quickly. It's all about managing variance and establishing statistical reliability, not achieving single-instance perfection.
The focus is on the robustness of the system, not the perfection of one output from the LLM.
Exactly. And that distinction leads right into shift 2. Effort no longer maps linearly to output.
Unpack that. In the deterministic world, if you were just better, a faster typist, a smarter debugger, a better architect, you got more leverage. Effort equaled better results.
A direct one-to-one translation. But this is where the whole equation gets broken by delegation. The constraint on your output is no longer your personal speed and skill, it's your ability to delegate and orchestrate.
Our source material had a really stark example of this.
Yeah, the contrast between two people. One person gets a 10x jump in output because they figured out how to set up a robust delegation loop using these models. Meanwhile, another person who is equally intelligent and working just as hard is grinding away manually and achieving far less.
Hold on. So if sheer effort is now secondary, what does that mean for how we train people? It suggests that all that time spent grinding, learning every shortcut in your old tools, being the fastest coder, that might actually be a low-leverage activity now.
Precisely. The bottleneck isn't execution speed anymore, it's the quality of your delegation setup. So why Karpathy called the new challenge a skill issue. The skill is hierarchical.
It's about developing the capacity for delegation, for orchestration, for systems design.
Not just the skill of individual execution. If you fail to learn that delegation skill, your personal effort just doesn't scale in this new economy. You're stuck trying to outrun a factory on foot.
Wow. Okay, so shift 3. This one feels like it hits technical leadership right where they live. The abstraction stack got inverted.
Yes. Historically, high-level reasoning collapsed downward cleanly into implementation code. You define the intent, and then you wrote the code to implement it. It's the basis for every product requirements document written in the last 30 years.
That model assumed the human was the reliable bridge between the big idea and the low-level execution.
And now, that process is often reversed, or at least it's radically restructured. Low-level implementation often expands upward from intent. You define the goal, you provide the constraints, and you let the system, the agent, the workflow, generate the artifacts. A full code base, a legal brief, a complex financial model. And then the human's job shifts.
It's not implementation anymore, it's verification.
Exactly. The structure changes from intent down to implementation to intent, then generated artifacts, then verification.
So the human job fundamentally changes. It moves from constructing something line by line
To supervising a construction crew. You're no longer mixing the mortar or laying the bricks. You are designing the system that does all that, and crucially, a system that checks its own work against your predefined goals and constraints.
supervising a construction crew. That's a fantastic metaphor because it immediately implies the skills are project management, quality control, systems design,
Right.
not just craft execution.
It really changes the meaning of engineering, doesn't it? From building the thing to designing the factory that builds the thing.
Mm.
And that factory needs to be self-evolving within limits, with correction methodologies and objective evaluations it has to pass.
Okay, finally, shift 4. The old boundaries between technical and non-technical have just collapsed.
They're gone. The crucial divide used to be engineer versus non-engineer, and it was all based on whether you understood the deterministic logic stack.
But now that's not the important distinction.
It's far less useful. The new divide is between someone who can delegate and orchestrate complex tasks versus someone who can't. The core professional challenge now is preserving your authority while you delegate the generation of work.
That's interesting. Engineers used to get authority for free just by writing the code. They could point to a line and justify the system's behavior.
They had the natural chain of custody. Ownership was implicit. But in the probabilistic world, the LLM generates the behavior, and that chain of custody is severed, or at least it's obscured.
You lose that automatic authority.
You do. You can now ship something that is technically correct without fully understanding why the model did it, which is terrifying for maintenance. Or, even worse, you can ship something wrong that looks correct and plausible, which is terrifying for the customer.
So the craft itself has to change.
It becomes about designing a workflow to delegate the bulk of the generation while ensuring human authority over what ultimately ships. And that applies to every single knowledge worker. Every profession is now becoming some version of this. Okay, before we actually start climbing this new skill tree, we have to establish the root node. Everything we're about to discuss, all 4 levels, it all flows from one single foundational insight.
Which is that we have to understand the true nature of the new machine we're dealing with.
Right. Our sources call LLMs truly alien components, and I think that's the perfect description. They are not just better versions of traditional software libraries. They are fundamentally different artifacts that have been inserted directly into the core of the knowledge stack.
That's the critical distinction, isn't it? An LLM isn't a computer program in the way we've always thought about it.
Not at all. It is a probabilistic token generator. It produces a statistically plausible sequence of words conditioned on its inputs and its training data. And crucially, it is stochastic, which means it introduces variance. It is fallible, meaning it can create things that are plausible but totally untrue. And it is opaque.
You can't just pop the hood and see what it's thinking.
You can't. You can't reliably reproduce its internal reasoning, and you definitely can't single step through its behavior like you could with old school logic code. This alien, opaque, stochastic component is the source of the entire earthquake.
And understanding that leads us to the foundational principle that holds the whole new skill tree together.
This is the absolute core idea. If you get this, you're on the right path. Probabilistic models require you to separate your decisions from the act of token generation.
Separate decisions from generation.
This is what separates the amateurs from the masters in this new field. The model is inherently good at generation. It can produce drafts, options, code snippets, summaries, hypotheses. It's a massive productive engine.
But what it should not be allowed to do
Is be the final authority, the judge, the security guard, or the decision maker in any high-stakes scenario.
So if a major workplace failure happens, say a model leaks proprietary data or approves a bad financial transaction, the source suggests that's almost always traceable to one design flaw.
Always. It's because we left the token generator to be the judge. We asked it what is true or what is safe or should this be approved, instead of using it only to generate possibilities that a deterministic system or a human could then verify.
Can you give a simple example?
Sure. A model is asked to summarize confidential meeting minutes and then decide if they should be emailed to a distribution list. The model is phenomenal at the summary part, that's generation. But it should never be allowed to approve sending the email. That's decisioning.
So the decision has to be made by something deterministic. The human, the surrounding workflow, some other system.
Correct. And this doesn't mean models can't be used for high-stakes tasks. It just means they need a sophisticated workflow harness built around them. And this harness provides the explicit definitions of correctness and the security guardrails that the model itself by its very nature, lacks.
So we're kind of shifting the technical burden. Instead of chasing this impossible dream of a perfect, all-knowing black box.
We're building deterministic, auditable guardrails around a very powerful, very useful, but inherently fallible engine.
That's a perfect summary. Let the model generate quickly, but preserve human or system authority through deliberate, auditable workflow design.
And if you skip this root node, if you let generation and decisioning get tangled up, the rest of the skills we're about to talk about just become chaotic and ineffective.
Yeah.
You'll spend all your time fighting the model instead of leveraging it.
With that root established, separating generation and decisioning, let's start climbing the skill tree. Level 1 is all about conditioning. This is the art of steering this probabilistic component, right? Getting reliable, low-variance outputs from an inherently variable tool.
Exactly. And the first node here is intent specification.
Which used to be seen as a soft skill, a managerial thing.
And now it's a truly technical skill. Think about how ambiguity works. In a traditional deterministic system, if your requirements are ambiguous, you might get an error or confusion, but the system doesn't just invent context, it stops, or it fails predictably.
But in a probabilistic system, ambiguity is, what did the source say?
Gasoline on the fire.
Right, because it doesn't stop. It just fills in the gaps with statistically plausible but contextually dangerous nonsense, the classic hallucination.
Precisely. So to prevent that, you have to define an extremely tight problem contract. You can't use general instructions anymore. You have to define the purpose of the output, the specific audience. Is this for an exec or a developer? The tight constraints on scope and length and explicit, unambiguous definitions of success all up front.
Can you give us an example, before and after, of a general request versus a tight contract?
Absolutely. A general request is, summarize this quarterly report. A tight contract is, summarize this Q3 financial report, which is document X for the executive board. The summary must be under 500 words. It must explicitly call out the 3 highest risk factors, and it must format the output as a markdown bulleted list, ensuring any financial figures are directly quoted from the source.
That level of specificity is no longer just managerial overhead?
It's a technical input. It dramatically reduces the model's freedom to hallucinate and increases the reliability of the output. It directly conditions its behavior.
That makes perfect sense. Okay, the second node in conditioning is context engineering. This feels like the new infrastructure layer.
It is. And failure here is probably the single biggest cause of model error, outside of just a bad prompt. Context failure means you're feeding the model the wrong material or missing material or conflicting instructions, or maybe the history gets truncated at a bad moment.
So if you're using something like retrieval augmented generation or RAG, this is everything.
It's the entire operational mechanism. We have to start treating the context window, that limited amount of information we feed the model for any given task, as the new I/O and databases of the AI stack. It defines the model's entire current reality.
And the skill isn't data science per se.
It's more like information architecture, but optimized for an LLM. It involves reliably deciding what goes into the context window, what's too distracting and stays out, what gets summarized versus what must be quoted verbatim. It's a massive new technical discipline around document chunking, indexing, relevance scoring, all of it.
So it's the difference between just shoveling a mountain of PDFs at the model and carefully curating the minimal high-signal knowledge it needs?
Exactly. The quality of your input data is now functionally equivalent to writing good code. And that brings us to the final step in conditioning, constraint design. If intent and context define the inputs, constraints define the sandbox for the output.
These are the deterministic fence posts.
That's a great way to put it. They're what turn the raw token generator, which is otherwise just a slot machine, into a reliable, predictable component. You have to define explicit boundaries.
Like what specifically?
Things like machine-readable output formats, strict JSON schemas, XML specifying rubrics for quality, demanding required citations that tie back to verifiable sources, restricting which tools the model is allowed to access, setting hard token budgets, defining explicit stop conditions.
So using a JSON schema isn't just about making the output look nice for another program.
No, it's a critical mechanism for imposing determinism on a probabilistic entity. If you require a JSON output with specific fields, and the model tries to give you free-form text, your deterministic validator catches the error immediately. Without that, you're just hoping the model feels like following instructions today.
You're relying on luck.
With constraints, the system becomes predictable and functional within its scope. It's how you build the bridge between the old deterministic world and the new probabilistic one. So once you've got a handle on conditioning, You can move up to level 2, authority. This entire layer is dedicated to solving that central paradox. How do you keep ownership and accountability when you didn't personally author the content?
This feels like the difference between saying, I used AI and saying, I know how to operate an AI system responsibly.
That's exactly it. And the first, and I would argue most critical, piece of authority is verification design.
Because the model generates plausible falsehoods.
So verification isn't optional. It's not a nice-to-have checkmark. It is the essential mechanism that replaces the old guarantee we used to get from authored logic.
Since you can't trace the internal logic, you have to rely on external verification.
You have to design explicit mandatory verification loops that run on every single generated output. And these can be deterministic, like, did the output validate against that JSON schema we just talked about? Does the generated code pass a simple unit test?
Or they can be procedural.
Right, requiring a human review, or using a second-pass critique model to check the work of the first one, or even using adversarial prompting, where another agent actively tries to break the generated output.
That idea of adversarial prompting is so interesting. It's like your system is testing its own work, a self-correcting organism.
It is, and it's essential for achieving reliability. The goal is to design verifications that ensure a tight alignment between what the system thinks it did and its actual correctness. If your verification method is lazy, your claim to authority is meaningless. You're just shipping unverified outputs.
Okay, the second node in authority is provenance and chain of custody. This feels huge. In the past, with code in GitHub, custody was implicit and easy to trace.
But now, if an LLM drafts a complex legal argument, your authority requires verifiable evidence backing every claim it makes.
So if the output makes any factual claim, the system has to be designed from day one to show exactly where that came from.
Exactly. We need source links, citations, quotes, the specific retrieved documents tied directly to the relevant part of the output. This is about establishing systems that author traceability as a first-class object, not as an afterthought.
It's not enough for the model to say it used the data. The workflow has to prove which specific document generated which specific sentence.
Precisely. You have to design your LLM workflow to be audited from day one. This moves the professional conversation from, did the model say it, which is an irrelevant question, to where did the model get that information and how was that source verified? That's the foundation of authority now.
And the third skill in level 2, which I think is maybe the most urgent for leaders right now, is permission envelopes. The source material is so adamant on this point, the model cannot be the security boundary.
This cannot be overstated. I agree, this is probably the defining security issue of 2026. As models evolve into agents that can take real-world actions, merging code, sending emails, moving money, the model's internal decision to do something is not a sufficient security check.
Why not?
Because the prompt that caused the action is stochastic. The model can be tricked, or it can hallucinate a reason to bypass a soft instruction you gave it.
So how do we solve that? How do we give a powerful agent the freedom to operate without it becoming a massive security risk?
You apply the principle of least privilege using old-school deterministic security tooling. The model should never have direct, unmediated access to critical systems. You cage the probabilistic agent with deterministic security rules.
So we're talking about things like strict allow lists for the functions it can call.
Yes. And scope tools that define exactly which files it can read or write. Mandatory human approval steps before any high-risk action is taken. And immutable audit trails logging every single function, call it even attempts.
So the real skill in designing an agent is less about the prompt and more about designing this sophisticated deterministic wrapper around it.
It's all about the wrapper. The LLM generates the intent to merge the code, but a deterministic function call has to validate the permissions, confirm the unit tests have passed, and require a two-factor human approval before that code ever hits the main branch.
Yeah.
That is how you preserve authority.
Okay, now we move into the higher levels of the skill tree. Level 3 is about workflows. This is where we stop treating AI like a cool chatbot for one-off tasks and start treating it like a scaled-out industrial factory for intelligence.
This is where the compounding leverage really starts to kick in. And the first, most important step to get here is learning to decompose into pipeline steps.
So stop treating the model like a monolith.
The single biggest mistake people make is interacting with it like a chatbot, asking it to do everything at once. That approach doesn't scale, it makes debugging impossible, and it increases the blast radius of any single failure.
So instead of one massive, perfect prompt, you treat the model as just one component in a structured, multi-step pipeline.
Exactly. The whole strategy is decomposition and modularity. You Break the large task into small, manageable steps. Step 1 might be retrieval. Step 2 is synthesis. Step 3 is drafting. Step 4 is self-critique.
Where you use the model to evaluate its own work.
Yes. And step 5 is final validation. You build intermediate artifacts at every stage. And you introduce checkmates to find points where the output has to meet some criteria, like passing a schema or having citations, before it can proceed.
I see the benefit immediately. You keep the generator away from the final decision, and if something fails, it's a local failure in one step, not a catastrophic failure of the whole process.
Precisely. If step 2 synthesis fails, you only have to debug that one component. And by defining these steps clearly, you make the whole workflow runnable and auditable by someone else. You transform a personal skill into transferable organizational leverage.
And if you can't trace the model's internal logic, this decomposition leads right to the next skill: failure mode taxonomy. In the old world, debugging was just tracing logic.
But you can't trace the logic here, so you have to classify and address failure modes based on which stage of the workflow they occurred in. Debugging is now about developing a complete, categorized taxonomy of errors.
So you have to stop just fiddling with the prompt.
You have to stop constantly fiddling with the prompt, the surface layer, and start identifying which internal layer of your workflow actually failed.
Let's dive into that a bit. What are some of those common failure types? How does that classification guide the fix?
You need to ask targeted questions tied to your system's architecture. For instance, if the output is factually incorrect, you have to ask, was the context missing or outdated? If so, the fix is to debug your array system. Did the retrieval mechanism just fail to find the right documents? The fix is to tweak your document chunking or vector database.
What if the model just hallucinated?
Then you need to know why. Did the constraints you applied conflict with each other? Maybe you asked for a 500-word summary and a strict JSON output, and it prioritized the wrong one. The fix is in your intent specification. Or did it just invent something because the source data was contradictory? Maybe the fix is to increase the temperature setting or add a second pass verification agent.
The skill is structural diagnosis, not prompt tweaking.
It's about knowing different failure types require different structural fixes. And if you can't look inside the model to trace its logic, that brings us to the third component: observability.
How do you compensate for the model's internal opacity?
You have to compensate by making the surrounding system overwhelmingly observable. You log everything deterministic and semi-deterministic around it.
What are we tracking?
Traces of all tool calls, exactly which inputs were used, every single document that was retrieved, and its confidence score. The intermediate outputs at every pipeline step, exactly which validations passed or failed, the timing, the token costs, all of it.
So we're taking those auditability and provenance skills from level 2 and just scaling them up to the entire workflow to ensure the whole system is legible.
It's the data stream that allows you to accurately diagnose those failure modes. If you can't see the inputs and the intermediate steps, you can't debug the system, period. And that brings us to the top. Level 4, compounding. This is the final stage of the skill tree where your leverage becomes durable and scalable over time, instead of just being a temporary speed boost, instead of just, as the source calls it, improvising faster.
Without this layer, every time a model updates, your whole system breaks, and you have to start from scratch. So the first skill here is building evaluation harnesses.
Absolutely essential. Without robust, automated evaluation, you can't reliably change any part of your system without being terrified. You're basically playing Russian roulette every time you tweak a prompt or switch to a new model version or add a new tool.
You iterate quickly, but you might be regressing even faster and not know it.
Exactly. So what does a good evaluation harness look like in practice? It doesn't have to be massive. Evils could be small, simple, golden sets of examples.
A set of known inputs that should produce known correct outputs.
Right. A set of 10 input documents that, when processed, have to yield a correct predefined output. You establish regression tests for key outcomes. You define scorecards and thresholds. The harness provides the safety net. If your new prompt variation passes the evils, you have verifiable, objective evidence that your change didn't break anything important.
And that evidence, that measurable confidence, is the currency of compounding leverage. It gives you the authority to move fast.
It does. And next, we have to look at feedback loops. The highest leverage comes not from optimizing a single prompt, but from designing agents that operate effectively in a continuous loop. This moves the system from simple input-output to something that is autonomous and self-improving.
What's the key difference between a single prompt and an effective feedback loop?
Think about asking for one perfect output versus running an agent that's designed to iteratively refine its own work. For example, an agent that can draft, then critique itself using a second set of criteria, then revise the draft based on that critique, then recheck against your human-defined verifications, and only then finalize.
Or in a data system, retrieve, then cite, then verify the citation.
And only then finalize. The beauty of the loop is that it fundamentally changes the risk profile. The generator becomes inherently less risky because errors get caught internally before they're ever shipped to a human or an external system.
And this dramatically reduces the reliance on having that one genius prompter on your team.
It makes the skill transferable. You don't need magic, you just need to be a meticulous builder of robust evaluation and feedback loops. The system becomes the genius, not the individual.
And finally, the last piece, drift management and governance. This is the ultimate layer of authority, just acknowledging that even if you build a perfect system today,
You're operating in a condition of continuous, relentless change. The models will update overnight. Your retrieval data will change. New teams will integrate their own components. Attackers will constantly adapt. This is not a static environment.
it's production infrastructure and it's constantly shifting. So what does governance look like for someone who isn't a traditional infra engineer?
In this context, it means versioning your critical components. You have to version the prompt, the constraints, the context structures, and the evaluation harnesses all together. You implement strict auditability policies. You treat all this workflow stuff like production infrastructure, using version control and strict deployment methodologies.
Because if you can't manage drift, all your leverage is temporary.
The next model update will wipe out weeks of optimization if you're not prepared. This is what makes your gains durable. Goodly. Okay, so now that we've climbed the whole skill tree conditioning, authority, workflows, and compounding, we need to talk about the broader implication, specifically for the vast majority of people listening who aren't software engineers.
Because if the core skills are things like intent specification, context engineering, and verification design, I can immediately see how this applies to a marketer, a lawyer, a business analyst, an HR professional.
This skill tree is universal across all knowledge work.
It really is.
Every profession is becoming some version of orchestrate probabilistic components while keeping authority. The core architecture of the problem is identical across all these different domains.
Our sources had a great example comparing a lawyer and an engineer.
Yes, a lawyer building a contract review workflow is climbing the exact same hierarchical skill tree as an engineer building a debugging agent for a code repository. The artifacts are different, but the skills are the same.
Let's walk through that parallel for a second. For the lawyer, what would the steps actually look like?
Okay, so the lawyer's workflow starts at level 1. Conditioning. Intent specification means defining the task precisely. Extract all clauses related to indemnity and termination, but only from contracts signed between 2018 and 2022, and output the result in this strict parsable table format.
And context engineering means making sure the ARGA system only pulls in the relevant case law and internal risk guidelines.
Exactly, excluding all the extraneous documents. Then they move to level 2, authority. How does the lawyer maintain authority?
Verification design.
Right. They build a deterministic check. Does the generated table include all the required fields? And a procedural check. A second model, or a junior associate, runs a critique on the extracted clauses to ensure they match the original contract wording perfectly. And provenance is critical. Every extracted clause must be linked directly to the page and paragraph number in the source PDF.
That's how you preserve legal authority. And then scaling up to level 3, workflows.
The lawyer breaks the review into a pipeline. Step 1, clause extraction. Step 2, risk scoring using an LLM with structured constraints. Step 3, red line suggestion generation. Step 4, final output compilation. This decomposition means if the risk score is wrong, they debug only the scoring prompt, not the entire monolithic review.
It's systems thinking, just applied to legal text, which makes that Factorio metaphor from our sources feel incredibly on point.
The video game Factorio. It's cited as the perfect training ground for these new skills.
For those who haven't played, what's the concept?
You crash land on a planet, and your job is to build a fully automated factory. You start by handcrafting a few basic items, but the game quickly forces you into automation, building conveyor belts, routing materials, automating your entire supply chain. If you don't automate, you simply can't progress.
And what makes it the perfect analogy is that it forces you to develop the exact instincts that scale in this new AI world.
It teaches decomposition, breaking complex production chains into simple, automatable steps. It teaches modularity so you can swap out a smelter without crashing the whole factory. Crucially, it forces you to master observability, seeing immediately where materials are bottlenecked.
And blast radius estimation. How badly does one failure affect the whole factory?
Exactly. We spent decades equating professional competence with manual authorship, the pride in writing every line of code or every paragraph of a report yourself. We celebrated the super engineers who were great solo practitioners.
But the world is now rewarding something fundamentally different.
It's rewarding the ability to step back, design robust workflows, introduce checkmates and constraints, and produce reliable outcomes, even when the core component, the LLM token generator, is stochastic and partially opaque.
So it's not that the skill required is less, it's just a fundamentally different skill.
You're forced to replace the deep comfort you once had in control, the certainty of deterministic code with the necessary discipline of systems, the ability to manage, audit, and govern a non-deterministic outcome.
So if you feel behind right now,
You are correctly perceiving that the technical stack and the rules of competence are different. Not that you are failing as a professional. The game has changed, and the next steps are structural, not superficial.
so the way forward seems pretty clear. The path isn't frantic tool chasing or just, outright denial of the changes. It's choosing to climb this new skill tree deliberately.
Integrating these 4 levels into your professional identity, no matter what your job title is.
The overarching goal remains the same. Orchestrate uncertainty without losing authority.
And we do that by intentionally separating generation from decisioning, conditioning the system's behavior with tight contracts and constraints, building robust, observable workflows, and making the whole system compound through evaluation and feedback loops.
And the new hierarchy of professional success. It won't be based on who codes the fastest or who has the most domain knowledge in the old sense.
No, it will be based on who can successfully orchestrate uncertainty without losing authority. Organizations that get this, that strategically scale this system's understanding across their entire workforce and stop using those restrictive old technical versus non-technical labels, they're the ones that will realize those massive compounding 10x speedups.
They'll be designing factories, not just crafting artifacts.
Exactly.
And I think that leads us to our final provocative thought for you. This era truly marks the end of the traditional technical versus non-technical divide. The choice facing every single knowledge worker now is no longer just about which career path to choose. It's whether to cling to the old hierarchies and the comfort of deterministic control, or to begin mastering the systems thinking required for the AI era, a challenge that is actively defining the new meaning of professional competence.